In this lecture, we are going to discuss about number system, and we will be going to cover the following contents. We will start with the various types of number system, like we have decimal number system, binary number system, hexadecimal number system, octal number system. Then we will discuss the basic concepts regarding the number system, like what is the base or radix of a number system, how we define the weight of a number system, and what is the most significant and the least significant digits in a number system. So basically, what is number system? How we define a number system? A number system is basically a way to represent numbers. So basically, how we express numbers or how we represent numbers, that particular system defines the number system. So most commonly used number system are that is the decimal number system, that is we use in the day-to-day life, that is the most common. And other number systems that we use in the computers, that can be binary number system or hexadecimal number system or octal number system. So basically, how we define the base or radix of a number system? In the mathematical numeral system, how we define the radix or base? It is basically the number of unique digits including the 0. That means any big number in a particular number system that can be expressed in terms of the combination of those unique digits. For example, if we talk about the decimal number system, the radix or base is defined as 10, because the unique digits we can represent in the decimal number system, that is the 10 digits from 0 to 9. That means any big number in the decimal number system we can represent with the combination of these unique digits in the range 0 to 9. So we can say the base or radix of decimal number system is 10. And the same way for the hexadecimal number system, the base is 16. That means total 16 unique digits are there in the hexadecimal number system. And in the octal number system, the base is 8. Octal means 8. Hexa means 16. And in the case of binary number system, the base is 2. That means only 2 unique digits can be defined in the binary number system, and any combination that can be made with only 2 digits here. So we can see here the various number systems with their base and the radix. For example, the most commonly used, that is the decimal number system with the radix 10, and unique digits defined here are 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we all are familiar with the decimal number system. The other number systems are binary, octal, and the hexadecimal. As we have discussed that the base or radix of binary number system is 2. For octal number system it is 8, and for hexadecimal number system it is 16. So in the case of binary, we can define only 2 unique digits, that is 0 and 1. And the binary digits 0 and 1 are called as bits. So any big number in the binary that consists of combination of only these 2 bits, that is 0 and 1. And in the octal number system, total we have 8 unique digits in the range from 0 to 7. That's why the base or radix is considered as 8. And in the case of hexadecimal number system, the range is from 0 to 9, and then A, B, C, D, E and F. So total 10 digits, that is from 0 to 9, and total we have 6 alphabets A, B, C, D, E, F. So 10 digits and 6 alphabets make total 16 unique digits, and therefore the base or radix of hexadecimal number system, that is 16. So any number can be represented in hexadecimal with the combination of any of the 10 digits or any of these 6 alphabets. So that can be any numeral combination or any alphabet combination or mix of numerals as well as alphabets, but only in this range, the numerals in the range 0 to 9 and the alphabets in the range A to F. So how we define the weight of a number system? Like all the number systems we have discussed, they are called as the positional number system. So every position of digit in the weighted number system, that is assigned a particular weight that depends upon the base or the radix of the system. For example, if we talk about the decimal number system, we have discussed that the base or radix here is 10, as it is having the total 10 unique digits combination. So any big number can be represented with this combination in the range 0 to 9. So every particular digit in the decimal number system, that is defined with a particular weight, and that is in terms of base raised to power. Base raised to power 0, base raised to power 1, base raised to power 2, 3, 4, 5 and so on. That means the rightmost digit that is assigned with the weight uh, that is 10 raised to power 0, and as we proceed from right to left, the weight that increases, like for the rightmost digit it is 10 raised to power 0, for next consecutive bit it is 10 raised to power 1 and so on, depending upon the number of digits in the decimal number system. And let's say if we have the fractional decimal number, so after the decimal point also we have digits, and the weight we represent as we proceed from left to right. So weights are assigned for the digits as 10 raised to power minus 1, minus 2, minus 3 and so on. So before the decimal point, if digit is there, so we proceed from right to left, and the weights they keep on increasing, 10 raised to power 0, 1, 2 and so on. And after the decimal point, the weight goes like this, 10 raised to power minus 1, minus 2, minus 3 and so on. For example, we can take one example of the decimal number system, like we have the decimal number 1024. So how we can represent 1024 in terms of the positional number system with the various weights assigned to the various positions. We can see 1024, as I have discussed that this is the rightmost digit. So rightmost digit is assigned with the weight 10 raised to power 0, and this particular digit is assigned with the weight 10 raised to power 1. This is with the 10 raised to power 2 and this is with 10 raised to power 3. So how we represent 1024? We take a particular digit and multiply that digit by its corresponding positional weight. For example, here the weight is 10 raised to power 3. So we multiply 1 with 10 raised to power 3. Then we add 0, that is multiplied with its corresponding weight, that is 10 raised to power 2, and then that is added with the next digit multiplied by its corresponding weight, that is 10 raised to power 1, and then that is further added with the next digit assigned with the weight 10 raised to power 0. So 4 is multiplied by 10 raised to power 0. So when we calculate this combination, 1 into 10 raised to power 3, 0 into 10 raised to power 2, 2 into 10 raised to power 1 and 4 into 10 raised to power 0. So here we have the summation of all these will be equal to 1024. And same way, let's say if we have the fractional decimal number, so here also we can assign the weights, that is 10 raised to power minus 1 for this digit and 10 raised to power minus 2 for this particular digit. So how we represent this number? The 1 with the its corresponding weight, so 1 is multiplied with 10 raised to power 2, then 0 is multiplied by its weight, that is 10 raised to power 1, then 8 is multiplied by its weight, that is 10 raised to power 0, then 2 is multiplied by its corresponding weight, that is 10 raised to power minus 1, and 5 is multiplied by 10 raised to power minus 2. Then we add all these digits and finally we get the summation as 108.25. So you can do the calculation and check that the result you are getting is 108.25. Same way, if we talk about the weight of a binary number system, so binary number system, the base is 2. So how we assign the weight here? Like in the decimal number system, the base was 10. So all the weights are in terms of 10 raised to power 0, 1, 2, 3, 4, or 10 raised to power minus 1, minus 2, minus 3, and so on. And same way for the binary number system, as base is 2, so weights are assigned as 2 raised to power 0, 1, 2, and so on before the fractional value, before the decimal point. And after the decimal point, if we see, the weights goes like this: 2 raised to power minus 1, minus 2, minus 3, and so on. So here we proceed from right to left, 0, 1, 2, 3, and here we proceed from left to right, minus 1, minus 2, minus 3, and so on. Same way, if we talk about the hexadecimal number system, how the weights goes, they goes in terms of 16 raised to power 0, 1, 2, 3, 4, and so on. And here minus 1, minus 2, minus 3, and so on. And if we go for the octal number system, they are in terms of 8 raised to power, like 8 raised to power 0, 1, 2, and so on. And after the decimal point, 8 raised to power minus 1, minus 2, minus 3, and so on. So in a number system, how we represent the most significant digit and the least significant digit? Like a number is expressed as a sequence of digits written from left to right. And if we see the digit that is on the left, that contribute higher value to the number, and they are considered as more significant as compared to digits on the right side. For example, if we see the decimal number 786, so this is having 3 digits, 7, 8, and 6. So 7 is considered to be most significant as it is on the extreme left side. So extreme left side, that is having the highest weight. Then the next weight is for the next consecutive digit, and the rightmost digit is having the least weight. So this is considered to be least significant digit, and this is considered to be most significant digit. So here 7 is most significant digit as its weight is 10 raised to power 2, that is 100. And for 6, the weight is 10 raised to power 0. 10 raised to power 0 is 1. So here the weight is least. So this is called as the least significant digit. And here the weight is highest. So this is considered to be the most significant digit. So conclusion is the leftmost digit, that is the most significant digit, and the rightmost digit, that is considered to be least significant digit. Same way, if we go for the binary number system, in the binary number system, the binary digit, that is called as bit. The short form of binary digit, that is called as bit. So here the most significant digit, that is also called as the most significant bit. So leftmost bit is the most significant bit, and the rightmost bit, that is considered to be the least significant bit. For example, if we have this number, so here 1 is the most significant bit and 0 is the least significant bit. And if we see this number here, the this one is the most significant bit and this 0 is the least significant bit. So if we see the summary of number system, so how we go for the counting in the decimal number system, like from the childhood, we have studied the decimal number system, like the number goes from 0, 1, 2, 3, 4. This is ascending order, 5, 6, 7, 8, 9. After 9, these are the 0 to 9, these are the unique digits in the decimal number system, total 10 digits. After these 10 digits counting, again the counting goes on repeating from the same unique digits. But here you see after 9 again we have 0, the cycle is repeated, but here the carry is also considered with 0. So after 9 we have 10. Then again we have repetition of all these unique digits and the counting goes from 0 to 9, but all are put with the carry 1. So we have counting from 10 to 19. After 19, again the unique digit will be repeated, that is 0, and the carry is again added with 1, so carry becomes 2. So after 19 we have 20, and the counting goes from 20 to 29. Then again it will be 0 and there will be one more carry, so it goes from 30 to 39, then 40 to 49, then 50 to 59, and so on. And if we go for the binary number system, as only two unique bits are there, that is 0 and 1. So after 0 and 1 counting, again there will be 0 and 1, but here the carry that is introduced, that is 1. In front of 0 we have written 1, and in front of 1 we have written 1. After this 0 and 1, again there will be 0 and 1, but here the carry is forwarded to 2. But as there is 2 representation in the binary is 1 0, because this is 0, this is 1, and corresponding to 2 we have representation as 1 0. So here 0 and 1 are repeated and carry is considered as 1 0 instead of writing 2, because 2 is not represented directly as 2, 2 is represented as 1 0. So here we have represented 2 as 1 0. Then the next combination will be with the carry 3, and 3 is written as 1 1. So 0 and 1 repetition with 3, and 3 is 1 1. Then again 0 and 1 representation with 4. So here 4 is represented as 100. So this is 0 1, 2 is represented as 1 0, then 3 is represented as 1 1, and 4 is represented as 100. So again we have 0 and 1 with 5, that is 1 0 1. Then 0 and 1 with 6, and so on. So counting goes like this. And if we go for the octal number system, here the digits are 0 to 7, total 8 unique digits. So after 7 we have again the repetition of 0 to 7, and here 0 to 7 they are added with the carry 1. So here counting goes like this. After 7 we have 1 0, 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, and 1 7. So after 7 again it will be 0, but carry is now 2. So counting goes from 2 0 to 2 7, then 3 0 to 3 7, and 4 0 to 4 7. It goes like this. And in the hexadecimal number system, the total unique digits are first 0 to 9 numerals, 10 numerals. Then after that we have 6 alphabets, A, B, C, D, E, and F. So these are the 16 unique digits in the hexadecimal. After F again we have 0, and 0 is put with the carry 1. So we counting goes like this. It will be 1 0, 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 1 7, 1 8, 1 9, then 1 A, 1 B, 1 C, 1 D, 1 E, 1 F. After F again there will be 0 and the carry becomes 2. So counting goes from 2 0 to 2F, then 3 0 to 3F, then 4 0 to 4F. Counting goes like this. So in this way we have covered the basic introduction of number system. We have discussed what are the various types of number system, what is the base or the radix of a number system, how we define the positional weight in a number system, and then we have discussed how to do the counting in the number system. So these are the references we have used. Thank you.